Hi friends, uh, I'm Jitendra Kumar. I'm taking the electrical machine design for the 7th semester students. In continuation of the previous lecture, we are now again continue about this thing, the modern machine manufacturing techniques. Under this, we are again discussing about the electrical engineering material. In the previous two lectures, we are discussing about this because there are lots of materials are using for manufacturing of the electrical devices. So there will be another types of material having the high resistivity. High resistivity material means it will offer a high resistance against the current, used to dissipate electrical energy as heat. That is in starting and regulating the devices for the motor. So it will be used for regulating or starting. Because at start, whenever we have to just start the machine, a very high current will flow over the motor winding. So just to control it, we are using the high resistance devices at start so that the current which will be flow at starting it will be low for the motor. So high dissipating electrical energy as heat, it will be associated with the high resistivity material. Materials of high resistivity are primarily alloys of different types of metals, just like nickel, silver, and iron. We are finding over this thing that there is this one is the nickel, this one is the silver, and this one is the iron structure, which we are opting for the high resistivity. Another, it can be identified in the three categories: first group, second group, and the third group. First group materials are used for using precision measuring instruments, and it can be also used for making standard resistances and making the resistance boxes. So these are the three types of application of the first group of material which we are offering there. Then there is a second group of material which we are using for the making of resistances, making for the rheostat, and making for the control devices. This will be under the second group. Third group, the application is used for making high temperature element for electric furnaces, heating devices, and the loading rheostats. So these are the three groups where the high resistivity materials will be categorized in the system. Materials used for precision work, important requirement is the stability of resistance over the period of time and during fluctuations of temperature. So over of this thing, we have to just concentrate the resistance. Normally, we are refer that the resistance offered by the resistance devices it will be in the plus minus. That it never be a stable or a fixed a value. So our main objective is that the resistance offered by by such kind of resistance it must be a fixed on a fixed value, either for a particular time or for the fluctuations in temperature. Magnetic is the one of the material which we are opting for this one. It has the low resistance temperature coefficient. Composition of the copper of 86%, magnesium as a 12%, and the nickel as a 2%. Nickel serves to reduce thermal EMF of contact with copper to a very low value of about 1 microvolt per degree Celsius. Resistivity of the magnesium is 0.43 into 10 to the power minus 6 ohm meter. Resistance temperature coefficient of the order of 1 into 10 to the power 10 to the power minus 5 per degree Celsius. These are the magnetic material which we are getting in a different types of forms. It can be in the form of a wire, it can be in the form of a sheet, and it can be this one. Next will be the large thermo EMF will be offered by this whenever we are using it as a rheostat. Then it will offer a large thermo EMF, large resistance temperature coefficient. It having the low cost. Then there is a constant term are used where large changes in resistances are allowed. Constantan having the copper of 60 to 65%, nickel of 35% to 40%. Soft Constantan wire has resistivity of 0.46 to 0.53 into 10 power minus 6 ohm meter. Hard Constantan wire has a resistance of 0.46 to 0.53 into 10 power minus 6 ohm meter. The resistance temperature coefficient is near to zero. Thermo EMF of 39 microvolts per degree Celsius with respect to the copper. Safely used up to a temperature of 500 degrees Celsius. Material used for the heating device is high working temperature is there, high melting point is there, so we are using a platinum. Is an incorrodible material with a high melting point of 1710 degrees Celsius with a resistivity of 0.117 into 10 to the power minus 6 ohm meter. It is also used in laboratory electric furnaces with a working temperature of 1300 degrees Celsius. The most extensively used high working temperature resistant materials are alloys of nickel, chromium and iron called nichrome and alloy of aluminum, iron and chromium. The resistivity of nichrome varies from 1.1 to 1.27 into 10 minus 6 ohm meter. Working temperature of the nichrome is 900 degrees Celsius to 1000 degrees Celsius. These are the different types of availability of the nichrome is available over here. It can be available in the form of a wire, it can be available in a chip, it can be available in a large strip. Electrical carbon materials are there. It is manufactured from graphite and other form of carbon core, etc. The conductivity of carbon used is slightly less than metals and alloys. It is used for making buses for electrical machines. Thank you for attending our lectures. It is related with the electrical machines, types of material we are using.